Hello, this is question 2 on your June 2022 statistics paper from Edexcel, the A-level one. So you have a manufacturer use a machine to make metal rods. The length of the rod L is normally distributed with this mean and a standard deviation that you don't know. Given that the proportion of metal rods less than this value is 2.5%, we have to find x, so the standard deviation. So remember, when I don't know the standard deviation or the mean or both, we are going to standardize our normal distribution. So we can use the calculator with normal 0, 1 and find the values that we are missing. So the idea is, let me show you. L is a normally distributed, the mean is 8, the standard deviation is unknown, and we know they are always going to give us a clue to find the standard deviation, which is this line here. So the probability that L is less than 0, that this value is 0.025, so 7902. 902. This is going to be 0.025, so 2.5%. I cannot go to the calculator, well, I have the values, but I cannot go to the calculator if I don't know the standard deviation. That's why we standardize our values. So we are going to work with Z, which is a normal 0, 1, standardizing the values. Remember, we do that doing x minus the mean divided by the standard deviation. And this Z will be normal 0, 1. Yeah, so what we are doing is probability of Z smaller than 7.092 minus the mean, which is 8, divided by the standard deviation, which is x, is still going to be 0.025 because it's the area, and the area stays the same. And now we can go to the calculator to inverse normal and find which value of Z, when Z again is 0, 1, is a normal 0, 1, has this area, has this probability. If we go to the calculator, inverse normal 0, 1, and this area, we find that this value here, so the whole thing, will be minus 1.95996, something else, yeah? And now we have an equation with x that we can solve. So our equation is just going to be 7.902 minus 8 divided by x is minus 1.95. And from here, x is 0.05 to 2 decimal places. That's what we have to try to prove, yeah? So this is the first part. Then B, calculate the proportion of metal rods that are between this value and this value in length. So now we know all the information about L. We know it's a normal 8, 0.05, and we can find any value. So we need to find for B probability that L is between 794 and 8.09. 8.09. We know L is a normal 8, 0.05. We go to the calculator, cumulative normal distribution. The lower value is this one, the upper value is this one, and we get 0.849, yeah? So this is the probability. Then for next one, it says the cost of producing a single metal rod is 20p. Metal rod where the length is smaller than this one is sold for scrap for 5p. Between this value and this value is sold for 50p, and greater than that is shortened by 10p, so with an extra cost of 10p, and then sold by for 50p. Calculate the expected profit per 500 of these metal rods. So the income, so the profit will be the income minus the cost. So the income, the total income, is going to be the number of rods that I have smaller than 0.94 multiplied by 5p, the number of rods that I have here multiplied by 50, and the number of rods that I have here multiplied by 50. That's the income. And then the cost is going to be my 500 rods multiplied by 20p plus what it costs me to reduce the size of these ones. Yeah, so I need to know how many rods I have in each group. So what I need to find is the proportion, the percentage, or the probability. Yeah, so I want the probability of being smaller than 0.94. That's the first thing I'm going to do. Smaller than 7.94. I do with the calculator normal CD, and this is 0.11507, so I'm going to write 51. Yeah, then probability between 794 and 809 is the one that we found before, 0.849, and probability of L greater than 8.09, again with the calculator, is going to be 0.03. With the calculator, or just subtracting from 1 the two values that we found. Yeah. Again, I'm going to round to 3 decimal places, for example. So the income is going to be 500 rods times the proportion of them that are smaller than 7.94 is 0.1151, and I sell these ones at 5p for 5p, so 0.05 plus the proportion that are in the correct size, and I sell them for 50p, so times 0.5 plus I sell these ones 0.036 at 50p. I will need to, or you can say it's 40, well, no, I think it's easier this way. Yeah, so this is the total income. And the cost, and don't worry too much about rounding and whole numbers, we can do all together. And the cost will be 500 times 0.2. I'm working, they give us pence and I'm working in pounds, but you can work in pence if you prefer. So each of them, the cost of producing them is 20 pence, so 20p, but I still have a few of them, so these ones, that to be able to sell them, I have to reduce the size, and that cost 10p each. Yeah, so the cost is going to be the cost of producing them all and the cost of cutting the ones that are too long, which are 0.036 times 0.1, so 10p. Yeah, that's the cost. So they are asking me the profit, yeah, to the nearest pound. So the profit would be all the income minus the cost. When you do that, all the values with the calculator, you get 122.31 something. And they are asking us to round to the nearest pound, so it will be 122 pounds. Yeah. And that's what we are doing. Yeah. So all the income and the cost. The income depends on how many I have in each. So I wouldn't, if you just start to multiply this by 500 to know exactly how many you have in this group, in this group, and this group, the numbers won't be nice. So you get in total like 501, so it gets a bit confusing. I will just do the whole thing together in the calculator without bothering too much about how many I have in each class, and then the number will look better. Yeah, it's just something to consider. And then the last bit says, the same manufacturer makes metal hinge in large batches. The hinge each have probability of 0.015 of having a fault, and the random sample of 200 hinge is taken from each batch, and the batch is accepted if fewer than 6 are faulty. Manufacturers aim for 95% of batches to be accepted, and explain whether the manufacturer is likely to achieve this aim. So this is not our normal distribution anymore. We have a probability of success, or in this case, having a fault, a fixed number of hinges. So we want to know what's the probability of have fewer than 6, because that's when the batch is going to be accepted. Yeah, so let's going to find what's the probability of, I'm going to call X the number of the batches, the number of faulty pieces. So this is binomial. I'm checking 200 pieces, and the probability of being faulty is 0.015. So I want to know what's the probability that I have less than 6 faulty pieces in each batch. And this is going to be a probability of X being smaller or equal than 5. Remember, with binomial distribution, as is a discrete variable, I don't have this value. In the calculator, I have smaller than, so I have to adjust. So I am able to use the calculator. So I go to binomial CD, X is 5 and 200 P 0.015, and I get this value. And this value is 0.9176, which means something like 92%. 92% of the batches have less than 6 faulty pieces, which is less than what they hope. So their aim is 95% to be accepted, and they are going to have only 92%. Yeah, so you have to say something like, what do they ask exactly? Explain whether the manufacturer is likely to achieve. So is not going to be the case, as 92% of the batches have 92% of batches have less than 6 faulty pieces. Yeah, faulty they were hinges. Yeah, and so it's less than they what they want. Yeah, and that's all with this exam question.